Hello, I'm Dr. John Martin Burgos, teacher in Statistics and Probability. Our objectives for today are identifies the appropriate rejection region for a given level of significance when the central limit theorem is to be used, and solve problems involving test hypotheses on population mean. But before we start our lesson, let us have our preparatory exercises. In this exercise, determine whether the statement is true or false. If false, modify the underlying words to make it true. In each question, I will be giving you 5 seconds to answer the question. So, if you are ready, let's start now. Number 1. The area under the normal curve is 1. Is it true or false? 5 seconds. Alright, time is up. The correct answer is true. Number 2. Under the normal curve, there are many z values. Is it true or is it false? 5 seconds. Yes, you are correct. The answer is true. The reason is because z-scores range from -3 standard deviations up to +3 standard deviations. Number 3. The level of significance alpha is equal to 0.01 gives 99% accuracy. Is it true or is it false? Okay, time is up. You are correct. The answer is true. Number 4. The level of significance alpha is equal to 0.05 gives 95% accuracy. True or false? Alright, time is up. The correct answer is true. Number 5. In a given problem, the notation sigma is a sample value. Is it true or is it false? 5 seconds. Okay, time is up. The correct answer is false. The reason is because it is a notation for population standard deviation. If you've got a perfect or correct, all correct answers, then that is an excellent result. So let's proceed now to our lesson. Identifies the appropriate rejection region for a given level of significance when the central limit theorem is to be used. Let us have a sample problem. The ABM Coffee Company claims that 20% of the coffee drinkers in Pinalaga, Manila prefer their brand the Ang Barako Mo coffee. To test the claim, a group of CMHS grade level students conducted a survey, and this is what they found out. Out of the 500 randomly selected residents, 95 indicated that AB and coffee is the reason why they wake up in the morning. Now the question is, can we believe the claim? Is the claim true? If the favorable responses were 50 or 60, it seems very reasonable to reject the claim. On the other hand, if the number of people who say they drink 80 and coffee every day reaches 100 or 20% of 500 or more in this survey, we can say without question that the ABM Coffee Company is telling the truth. But the number that the researchers got was 95, a proportion so close to the claim that is 100. So the question is, do we reject the claim outright? Can we accept it? You know that it is possible to get a different set of responses if we will get a different sample of 500 residents. Now, in order to make a correct decision, we need to set up the rejection region. So the question is, what is the rejection region? Rejection region is a range of values such that if the test statistics, for example, C or T or P, falls into that range, we decide to reject the null hypothesis for the HO in favor of the alternate hypothesis or HA, according to Keller and Mara. Now, we will now illustrate how the rejection region is determined when alpha is equal to 0.05. For a left-tail test or one-tail directional test, the rejection region will have an area equal to 0.05 at the extreme left side of the normal curve. You can see the figure below. The line that divides the rejection region and the non-rejection region corresponds to a z-value that we call critical value. This critical value may be found in our Z table. Since the rejection region or the red region in the figure that you saw has an area equal to 0.05, we have to look at our Z table for the corresponding Z value. Now, were you able to locate it? It's exactly between negative 1.64 and negative 1.65. That means the Z value we are looking for is negative 1.645. Now, remember this. We use this diagram in our alternate hypothesis or HA uses the symbol less than. Using the same argument and also because of our normal curve is symmetric, our critical value for a right-tailed test or one-tailed directional test is when 0.05 must be 1.645. Also, remember that we use this diagram if our alternate hypothesis or HA uses the symbol greater than. Remember also that we use the two-tailed test if we are using the symbol not equal to in the alternate hypothesis or HA. The diagram is a little bit different if we are using a two-tailed test or directional test. The 0.05 alpha will be divided equally into two at both tails of the normal. Let's proceed to the next objective. Solve problems involving test of hypotheses on population mean. The sample distribution of a proportion approximately follows a standardized normal distribution. The test statistic for proportion P sub O is given as follows. Z is equal to P hat minus P sub O over the square root of P sub O times Q sub O divided by N, where P hat is equal to X over N. P hat is the sample proportion, X is the number of successes, N is the sample size, P sub O is the hypothesized population proportion, and Q sub O is the 1 minus P sub O. Now take note that P sub O is approximately normal for N times P sub O, which is greater than 5, and N times Q sub O, which is greater than 5. Let's have an example. A local government official claims that only up to 25% of all public school students in the city own an electronic gadget that can be used for distance learning like cell phones, tablets, or laptops. To test the claim, a group of 11 statistics students made a survey and found out that out of 1,000 randomly selected students, 275 indicated that they are ready for online learning. Now, can we infer from the data that the local coefficient is true to this claim? Let us use alpha is equal to 0.05. For our solution, the null hypothesis or the HO, the proportion of students who own an electronic gadget is at most 25%. That is, if V sub O is less than or equal to 0.25. But in the alternate hypothesis, the proportion of students who own an electronic gadget is more than 25%, or P sub O is greater than 0.25. Take note that we are using the symbol greater than in our alternate hypothesis because we hope to show that the obtained sample of 275 is significantly greater than 250, the 25% of 1,000. The second thing we have to consider is that it is one-term test or 0.05. The third thing we have to consider is the n times p sub o greater than 5? The answer is yes. Is n times q sub o greater than 5? The answer is yes. So, to compute that, 1,000 times 0.25 is equal to 250. And n times q sub o is equal to 1,000 times 0.75 is equal to 750. So in this case, we will use the Z test. To compute for the Z test, we have P hat minus P sub O over the square root of P sub O times Q sub O over N is equal to 0.275 minus 0.25 over the square root of 0.25 times 0.75 over 1,000. The total answer or the total computation is 1.83. To compute for the p hat, we have x over n, and to substitute the given values, we have 275 over 1,000 is equal to 0.275. So how did we get that p sub o? It is 1 minus p sub o, or 1 minus 0.25 is equal to 0.75. And the fifth thing that we have to consider is we have to set up the rejection region and the critical values, which is in the rejection region of 1.8. The sixth thing that we have to consider is the decision rule for right hand test. If the computed value is greater than or equal to the critical value, but if we will reject the null hypothesis, otherwise we will not reject the null hypothesis. So compare the computed value with the critical value. Since 1.83 is greater than 1.645, the decision will be to reject the null hypothesis. So, in making a conclusion, we have the conclusion that there is enough evidence to reject the claim of the government official. There is significant difference between the sample proportion and the hypothesized population proportion. It is safe to say that the proportion of students who own an electronic gadget in the city is more than 25%. So, in this lesson, what have we learned? At alpha, which is 0.05, the critical value from a left tail test is negative 1.645. Secondly, at alpha, which is 0.05, the critical value for a right hand test is 1.645. Third one is at alpha, which is equal to 0.05. The critical values for a two-tailed test is positive or negative 1.36. The rejection region is also called the critical region. The critical value is also called the terminal value, and the sampling distribution of P has a mean of P sub O and a standard deviation which is equal to the square root of P sub O times Q sub O over N. Now let us now solve the problem presented in the beginning of this module, the ABM of B. So what will be the solution to that problem? The solution is that in the alternate hypothesis or the H form, the proportion of residents in the LAGA that prefer the ABM coffee is 20% or more, or P sub O is greater than or equal to 0.20. But in the alternate hypothesis, the proportion of residents in Pinalaga that prefer the ABM coffee is less than 20%, or PO is less than 0.20. Now take note of this. We are using the symbol less than in our alternate hypothesis because we have to prove that the obtained sample value 95 is significantly lesser than 100, the 20% of 500. The second thing that we have to consider is that it is a one-term test at alpha, which is 0.05. The third thing that we have to consider is the question: is n times p sub o greater than 5? The answer is yes. Is n times q sub o greater than 5? The answer is yes. Because n times p sub o is equal to 500 times 0.20 is equal to 100. And n times q sub o is equal to 500 times 0.80 is equal to 400. The fourth thing that we have to consider is we have to use the test. Now, to compute the value or to substitute the values in the formula, we have C is equal to P hat minus P sub O over the square root of P sub O times Q sub O over N is equal to 0.30 minus 0.20 over the square root of 0.20 times 0.80 divided by 500. So the answer will be negative 0.86, which is the computed value. Now, P sub hat, or compute for the P sub hat, we have x over n, and to substitute the values, we have 95 over 500 is equal to 0.30. In computing for the Q sub O, Q sub O is equal to 1 minus P sub O, or 1 minus 0.20 is equal to 0.80. The fifth thing that we have to consider is we have to set up the rejection region, and the critical value is negative 0.56. The decision for the rule is for the left tail test. If the computed value is less than or equal to the critical value, we have to reject the HO or the null hypothesis. Otherwise, we cannot reject the null hypothesis. Compare the computed value with the critical value. Since negative 0.56 is greater than negative 1.645, the decision will be do not reject the null hypothesis for the HO. So, what will be the conclusion? There is not enough evidence to reject the claim of AB and of a company. There is no significant difference between the sample proportion and the hypothesis population proportion. It is safe to say that 20% of the Nalaga residents prefer AB and of. So, let's have an exercise. You have to solve the following problems. Now, in the problem that I'm giving you, I will give you 5 minutes to find the solution to the problem, applying everything that we have learned, all the steps that we have discussed. You have to apply this in order to find the solution to this problem. So, let us have the problem now. If you are ready. There were 20 left-handed students from a sample of 122 students from Langley National High School were taken. Using alpha, which is equal to 0.05 as the level of significance, test hypothesis that less than 20% of students are left-handed. If you are ready, I will give you 5 minutes to solve the problem using the lectures, the points, the steps that we discussed. If you are ready, you may start now. Now let's answer the question. The first thing we have to do is to state the null and alternate hypothesis. So the null hypothesis will be P is equal to 0.20 and the alternate hypothesis will be P is less than 0.20 or less than 20% based from what is stated in the problem. The level of significance is alpha is equal to 0.05. So we need to calculate the appropriate test statistic. The given is x is equal to 20, n is equal to 121, and p is equal to 20% or 0.20. So to calculate for the p hat, we have x over n, and to substitute the values, we have 20 over 121 is equal to 0.165. To compute for the Q sub O, we have 1 minus P sub O, and substituting the values, we have 1 minus 0.20 for the 20% is equal to 0.18. To compute for the Z value of the Z test, we have P hat minus P sub O over the square root of P sub O times Q sub O over N is equal to 0.165 minus 0.20 over the square root of 0.20 times 0.80 over 121. The computed value will be negative 0.972. Now, the level of significance is alpha is equal to 0.05 or 5%. The alternate hypothesis is less than 0.20. Therefore, it is one-time test and C is equal to positive or negative 1.645. Since the answer is negative 0.972, therefore we have to choose negative 1.645. To determine the critical value, the Z subcritical is equal to negative 1.645. As we can see in the figure, the decision will be, since the computed test statistic of Z computed is equal to negative 0.972, which is greater than the critical value, we fail to reject the null hypothesis. So, for our conclusion, we therefore conclude that at 0.05 level of significance, the evidence that 20% of the students are left-handed is not enough. Let's proceed to our question and answer portion. If you have any questions, please post it in the comment section below. There is a question here. It is related to the first question that I gave in the preparatory exercises. It says here, why is the area under the norm of the curve 1? So to answer that question, the total area under the curve is always equal to 1. This is because the value of a random variable has to lie somewhere in the sample space. In other words, the probability that the value of a random variable is equal to 1, something is 1. The second question is, Do all normal distributions have an area of 1? The standard normal distribution is used to find probability. The standard normal distribution is a probability distribution. So the area under the curve between 2 points tells you the probability of variables taking on a range of values is equal to 1 or 100%. Therefore, the total area under the curve is 1 or 100%. Thank you for listening. I hope you learned our lesson and I hope you will be able to answer the questions or the exercises or the examinations or the quizzes to be given to you by your teachers. See you for the next lesson. Thank you for listening and God bless.